Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like part modeling, surface modeling, sheet metal enclosure design, plastic components design, product design, reverse engineering, simulation, and many more tips and tricks in SolidWorks. Hi, today I am going to explain how to make elbow bend pipe with two methods, that is sheet metal and with plates. So left side you can see method 1, thickness more than 6 mm, and method 2, thickness less than 6 mm. See here, this is a plate which is having thickness more than 6 mm. See, this is the one, see left side pipe, and this is a duct. The thickness is less than 6 mm. So this is done in sheet metal. So as we know that if the thickness of the metal is less than 1/4 inch or 6 mm is considered as a plate. So this is the plate, left side one, and if the thickness is less than 6 mm is considered as sheet metal. So this is the right side one. So I am going to explain both the methods. See, this is the pipe thickness more than 6 mm. So this is done in solid modeling, and I am going to show you how to extract flat sheets or flat plates from the pipe. And the other one is completely in sheet metal module. See, you can see sheet metal, there is no solid modeling, and I am going to show you how to create this pipe in sheet metal module. So I am going to explain both the methods. So let's start now. I am going to explain method 1, thickness more than 6 mm. Select the front plane, go to sketch, select the polygon, so click here. So before closing the dialog box, we have to select the number of sides. So I have taken 12 sides. Say OK. Select this line, make it horizontal, and this line, take center line and join this point. See here. Now this is 950. Okay, say OK. So this is the reference sketch. Now select the front plane once again, go to convert entities, and here we can draw one center line, or else we can select this and convert entity and this column. Select these two lines and make it construction. So now we have to trim. So we can trim these two. So we got 1/4 of this polygon. Say OK. So we have to hide this reference sketch. So we can have only this one. Now select the top plane, select this sketch. So slightly rotate it, so better visibility. Now select the circle, place it somewhere here, and select this end point and this center of the circle, make it coincide. So this diameter is 550. Okay, so say okay. So we have two sketches. Go to feature, select swept boss, select the circle and select this line. So it automatically selects the continuity of these lines. Simply say okay. Now we have to apply the shell feature. Go to shell. Here I am going to take 6.5. So you can take any value, but it should be more than 6 mm as per this standard. So I am going to design pipe with plate section. So 6.5, and we have to select these two faces. So faces to remove and say okay. So there is a tube here. So it's a pipe. Now we have to select the front plane. Go to sketch, draw one circle anywhere in between the outer edges. So you can, for constraining, you can assign any dimension. So 1671, say okay. So it is in between. Now go to extruded cut and select mid plane, and here thickness you can take 2 mm, depends on the precision. So 2 or 4 mm. So I am taking 2 mm. See, it is divided into two parts at this location. See here. Now we have to create planes. So select the plane and select this edge. Simply select this edge. So it select the circle and creates the plane. See here. So create one more plane at this edge and third plane at this edge. So at this bottom we have top plane. See here, this is the top plane, and the other side we have right plane. So we don't have to create planes here. Now we have to split this pipe into 4 pieces, so 4 parts. So we have to use a split command here. So go to features, split. So for split we have to select this plane 1, plane 2 and plane 3. So we have to say cut part. So it is divided into 4 pieces. See here, 1, 2, 3, 4. So we have to select these, whichever the resulting bodies, we have to select it and say okay. See here, if I don't split, I have single part, single solid body. When I make the split, it is divided into 4. See, we need a flat pattern of these pieces. So what we have to do here is, we have to select whichever the part we wanted. For example, I am going to take this one. See. So we have to right click and insert part. We have to select this and here whichever the template we wanted. So we are going to create new part from this. So I am going to select this part and say OK. So it is asking change units to derived part to the unit of the base. So we can say S, and we have to select the folder. So it is the we have the split one. So I am going to save this. See here. Now we have to make flat pattern. So how do we do this? So we have to go to sheet metal and insert bend, and we have to select this edge and simply say OK. So it is converted into sheet metal. See here. Then we can see the flat pattern. See here, this is the flat pattern. So we have to derive individually and we have to create individual parts in solid modeling. Similarly, if I am going to show you the other one, select this, right click, insert part, select the template, say OK. After that, so I am going to save it as split 2 and say OK. So we have to go to sheet metal, insert bend, and select this edge. We have to select this edge. See here, and say OK, and it converts to flat pattern. See here, one of the drawback is we can't create all the splitted parts in a single part file. So we have to derive these parts and we have to place them in the drawing. So we have to place in this manner. So these are the individual parts. This part is different. This is. So one more technique is, instead of split part, we can do with surface flatten in surface module. See, we can select this and simply select this one and say we have to select this edge, automatically to create the surface. So if you want to see this, we can hide solid. See, this is the flat one. So we can check the flat pattern in this manner also. This is one more method. So this is how we create pipe in solid modeling, which is more than 6 mm. So next I am going to explain method 2, thickness less than 6 mm in sheet metal. Select the front plane, go to sketch, and here we have to draw a polygon. So this is 24. Select any line and make it horizontal. So this diameter is 1000. So it is constrained now. So we have to make it visible. See here. Select the front plane once again. Go to sketch. So we have to draw construction lines. Come out of the sketch. See here. So I am going to show the planes. So we have to create one axis. See here. Now with each segment we have to create the plane. So select the plane and we have to select this axis and this line. So we have to create these planes with these segments. So I am going to hide this. See, we now select the top plane, go to sketch. So now we have to create one circle. See here. We have to make sure that it is coincide with this endpoint. So the diameter is 200 mm. So this is one sketch. Next we have to select each plane. So I have selected this plane, go to sketch, select this point and this point, make it coincide. This is 200 mm. So we have to create circles till the end. So we have to create circles in this manner on each plane. See here. Then we have to modify each sketch. See here, I am going to hide this, draw one center line joining this point, and trim the inside line. So you can keep 5 mm. See, this point should be at this arc, so we have to draw 3-point arc, place it here and select this circle and this circle, make it co-radial. So we have to coincide with this arc, so it is fully constrained. Then we have to select this point and make it construction, and select this line, make it construction. So we have to do for each and every circle. See, I have created sketch in this manner. So I am going to show you once again. See, this is the circle and this is a construction line, in order to maintain the gap in between the end points of the sheet metal. So I have created in this manner. Now I am going to create loft. So we have to go to sheet metal. So this is modeling purely in sheet metal module. So select the loft and select this line and this line. So we have to select this. See here. So keep as it is in default. So I have taken 0.1 as it is and 1 mm, radius is 1 mm. See, it is created. I am going to hide these sketches. See here. See, it looks in this manner. So a flat sheet is gradually going to bend in this manner. So it is creating segments. So next I am going to unhide this. See, we have to select this top sketch. We have to go to loft and we have to select the top sketch. See, so I am going to select from the graphical window. So we have to select the sketch from here. See, should be very much careful. So this is how it is going to create, and say OK. Select the loft, select the sketch, this top sketch and this one. Say OK. Select the sketch, see here. So I am going to hide these sketches. So it is going to create in manner. See, like in solid modeling, we don't have to split each surfaces. So here, see, we can see each segment in each flat pattern. So once you unsuppress this, so it creates flat pattern of the individual segment. So here what we can do is we can create a number of configurations. See here, we can create this flat pattern. See here, only thing is we have to unsuppress this segment individually. So in configuration 1, I have unsuppressed this bottom segment, and second one I have unsuppressed the second segment. So we can create 8 configurations with each segment, and all the configuration will be in same part file. So in previous model, so we have created individual segments in separate parts using insert part. See here, I am showing once again. So we have created in this manner, and we have saved individual segment in individual part. So we will have different part files. But in this sheet metal module, we will have different configurations. See here, for each segment. So this is the advantage in creating this bend pipe in sheet metal module. So this is brief about how to make elbow bend pipe in sheet metal and plates in solid modeling. Thanks for watching.